Hi everyone, welcome back to another video of CambiHub, and in today's video we'll be doing IGCSE Computer Science 0478 Chapter 5, the Internet and its uses. Starting with the chapter, see, the chapter's name is Internet and it talks about its uses. We are going to talk about the threat issues, the security, and also we are going to talk about how does the internet work and some of the crucial concepts which is really necessary for you as an IGCSE student or you as a computer science student to know for your examination. However, this is a revision video, it's a summarization video. I recommend, even if you haven't studied the chapter before, just go and read through the book, give it 30 minutes, read through the book, come back to the video, and then focus on the concepts, because this is a revision video. So it will be helpful if you read the book first. Even if you don't understand it, I am going to do that job, that's my job. But we recommend that you do that first and then listen to this video. So starting with the chapter, the first concept that we need to understand is that internet is made up of two words, which is interconnected networks. When we talk about internet, or if you have to define an internet, you would say it's an interconnected network of computers from all over the world, right? So it's everything is connected to each other, they make a network, and the devices are connected from all over the world, right? This is what internet is. It is pretty easy to define internet if you think about it, right? So there is nothing as to rote learn the definitions and stuff in IGCSE computer science. You can also make it, or you can also think from your own. You can also make a definition by yourself, right? So that's what we focus on generally. Now there's a difference between www and the internet. Www is the World Wide Web, right? Www is a collection of web pages, whereas internet is contains other things than just the collection of web pages. It is messaging, it is calling, chatting, servers, right? So www is a part of the internet, right? Now www uses the hypertext transfer protocol, which is HTTP, whereas the internet uses a protocol which is TCP/IP, TCP/IP. So these are the two protocols that both of them use, and this is the difference between www and the internet. Moving on to a paths of a URL. For example, we have the Google Meet link here, www.meet.google.com. The www is obviously our domain host, meet.google is our domain name, and .com is our domain type. Coming to the next topic, as we studied that the protocols are HTTP and HTTPS, right? This S stands for SSL certificate. This S stands for secure. So if you're on a website and you see that there's only HTTP and there's no S, the website is not secure. The website should have a lock sign, a padlock, which also signifies that the website is secure, and this S also signifies that there's an SSL certificate. Now SSL certificate is a digital certificate which shows an encryption, right, which shows that the site is secure. And so how does the SSL certificate work? So when you load a website, your browser will first ask the website to send to the web server to send the website's SSL certificate. Then your browser is going to verify that certificate. If the certificate is verified, then only a connection will be established. Otherwise your browser won't let you connect to that IP, won't let you open that website, right? In simpler terms. The modern version of SSL is also called TLS, which is transport layer service, transport layer protocol. But you do not need to learn whatever that is or why that is. Just learn that the modern version of SSL or the latest version of SSL is called TLS, right? Now what are the some of the features? Before we move on to cookies, let's focus on some of the features of web browser. Obviously we all use web browsers. We use Chrome, we use Firefox, we use Safari, we use Microsoft Edge. All of these are examples of web browsers. What do web browsers contain? They have a home page, obviously. They have bookmarks, right? There's the star icon in the Chrome, right? Chrome web browser. The star icon at the top, on the top, allows you to bookmark pages, right? So bookmarking is an option. History, browsers show history. There's an option to navigate backward and forward, the button on the top. There's an option to reload the page. There's an option to store cookies. There's an option for hyperlinks, right? Okay, now let's come to cookies. There are two. So what are cookies? Cookies are small data files that are stored on your system. Now if you have gone to a website or something, they say that this is our cookie policy, please allow us to I mean, the website might not open, the website might ask you for the cookies. What is this cookies? So cookies are small data files, small text files which are stored in your system, which basically stores information about you. So if a website wants to store information about you, your likings, whatever you search, so that it can show you relevant ads, it will store it as cookies. Now there are two types of cookies. We have session cookies and we have persistent cookies. So session cookies are temporary cookies. As soon as you close the browser, or as soon as the session terminates, or as soon as the page closes, these cookies are deleted. These cookies are terminated, right? An example of this is the virtual cart or a virtual basket that we have on these e-commerce websites, where we can add our favorite items into the cart and then check out. But if we close the app without checking out, then obviously the cart, most in some of the apps, it vanishes, right? So this is an example of a session cookie. Persistent cookies are permanent, right? So persistent cookie are, which store your likings, or which store your login and id password details. When you go to the website, sometimes there's an option to save your login id password, and when you log in, it automatically flashes the password in the dialog boxes. So obviously persistent cookies, and they delete when the user tries to delete it, right? Or if somebody tries to delete it, or if they reach their expiry date, right? So these are the two kind of cookies. Let's understand how does a web browser access the web page. So we just understand how does a web browser sees the SSL certificate. Now let's understand how does the web browser access the web page. So I've taken the image from your book, from Hodder Education book. I don't know if you use Cambridge book or the Hodder book, but both of them have decent diagrams. However, Hodder one is more detailed, so that's why I've taken the diagram from there. When we talk about how this is an important diagram, right? Because from the 2024 series, Cambridge has started asking, or 2023 series, Cambridge has started asking for diagrams in the paper, 4 marks of diagrams in the paper. So you should learn all of the important diagrams. Even if you don't know any diagram, you can make it from yourself also, but make sure to mention all of the points. Even if your diagram does not match the marking scheme, it is totally fine. The examiners check your diagram from the written criteria of the marking scheme. So even if it is visually not the same, but it contains all of the requirements, right? It is visually not same with the sample diagram in the marking scheme, but you have made all of the requirements, it will be accepted. You will be granted you would be given full marks. So how do we access a web page? First, the user is going to type a URL. For example, if I want to go to YouTube, I will say youtube.com. I will type it in my browser search bar. The URL is sent to a DNS server. So a URL will be sent to this DNS server. From the computer, the URL will be sent to a DNS server. If so, DNS server will look for the address of the website. It will look for the IP address of the website, because we need to send the address to the system, to our web browser, so that I can connect the web browser to the website, right? So that's why we look for the URL is sent to a DNS server, a server which contains the a lot of addresses of all websites, and that DNS server will look for the IP address of the website. If the IP address is not found, a higher level or an alternate DNS server is used. So suppose this DNS server is not able to find the IP address, a higher DNS server will be used, right? So this DNS server, what it will do, it will send it to my PC, obviously, because I was the one who requested it and I want to open the web page, but it will also send it to the other DNS which doesn't have this IP address, so that it also gets updated, right? Now the browser will, as soon as the IP is sent back, the browser is going to render the web page into the HTML web page and present it in front of you. Coming to the next topic, which talks about digital currency. So when we talk about digital currency is a currency that is in digital format. It is intangible. It does not exist in a physical format. We cannot touch it, right? So suppose we have two people, Ark and Pranay, and we want to send money, right? So how does this, so now we are going to understand in digital currency, what is the difference between a centralized and what is the difference between a decentralized system. In a centralized system, when Ark is going to send money to me, he cannot directly send it. First, Ark will contact, using Ark's bank, it will contact his bank. Using the bank, they will send it to they will send it to my bank, but in between, the central bank is going to monitor this transaction. So this is a centralized system. Whereas when we talk about decentralized system, there is no central bank in between, right? There is no monitoring like this. Now we are going to understand a similar process, which is blockchain, a chain of blocks which hold the information of all of the transactions. right? So let's see how does a blockchain work. So whenever a transaction is done, a block is created, right, as you can see, and it's a chain of blocks. So the transaction history, everything, the data about transaction, right, the blocks contain. The first block in the chain is called the genesis block, right? The first block in the chain is called the genesis block. Now these blocks have two things. They have a hash value and they have a previous hash value. Now since this is the first block, it will not have a previous hash value, so it is 0000, and this is its current hash value. When we move to the next block, its previous hash value is going to be the previous block's hash value, and this is its current hash value, and so on. This is how the blockchain works. Now a block contains three things. It contains obviously the data of the transaction, it contains a hash value, and it contains a previous hash value. Now, why is blockchain secure? Why do we use it? Because the transaction history is public. So whenever you do a transaction, a copy of it is sent to everyone on the network, or everyone on it, so that it can be monitored. However, people get confused at how is this secure? This is secure because firstly, there is no central bank that is monitoring, and secondly, it is open to everyone, so it is more secure because nobody can tamper with your transaction, but they can see what transaction you are doing, right? It is decentralized, it has a previous hash value. Now there is proof of work, right? Now what happens when your phone hangs, right? When if your phone is hanging and you click it multiple times, it gets, it further gets laggy, it hangs more, right? So to prevent this with a blockchain, hackers adding blocks again and again and again, or removing a lot of blocks, from preventing this damage to the chain, we create proof of work. Whenever a new block is created, a 10 minutes time period is there's a wait time period of 10 minutes, and then the next thing happens. Each transaction is monitored by miners. Now what are miners? Miners work as the police, right? Miners work, they monitor the transaction, they monitor everything, whatever is, they are the ones who is responsible to see. You can, if you are on the network, you can also become a miner, and you will get a commission with each transaction. Whatever transaction is made between any person on the network, a small commission is given to the miners. Okay, whenever a new block is generated, now whenever, even if we generate a new block, its copy is sent to all users, right? Its copy will be sent to all users. A transaction cannot be changed without the permission of the members, and each block is checked and scanned before it is added to the blockchain. So these are the few features which make blockchain secure, right? Moving on to cyber attacks, let's talk about few cyber attacks. So cyber security or cyber attacks, again a very important topic. The first kind of cyber attack that we want to talk about is a brute force attack. What is a brute force attack? I know, I'm really sure even you would have tried this attack some time in your life, or you would do it some time, right? What a brute force attack is, you have a list of passwords and you keep on entering the password and guessing the password of that user. Now, this is a pretty small example of brute force attack. When we do it on a larger scale with company systems or with organizations, hackers have very complex bots, they have very complex computers which have a huge list of passwords, right? And they enter and check. Data interception, this is when you are transferring packets from sender A to sender B, that transmission or that connection will be monitored by a packet sniffer, by a hacker, also called the packet sniffer, because they're sniffing the packet in between. DDoS attack is when, so again, I told you the example of when your phone starts to lag a little bit, but when you keep on pressing it in rage, right, it hangs more. So the same logic applies here. There's a server and we request for files from the server. But DDoS attack, an outsider or a hacker is going to give so many requests to the server that the server is going to fail. Right? This is mostly done to damage the reputation of a company or an organization. For example, Google Drive, right? That's also a server where I store my files, and for example, I'm requesting for files. Some hacker tries to hack Google Drive using so many computers that hacker creates a botnet. He makes all of the computers the bot, right? It makes a botnet is made, and then they request for files from so many accounts to Google Drive that Google Drive crashes. This can be done to damage Google's reputation, right? Obviously this cannot be done because Google Drive is a highly secure and a renowned and a old platform, so they have experience, they have their team, right? Google being one of the biggest companies in the world. Just as an example, I was explaining it to you. Now, hacking, obviously, there are two types of hacking, which is ethical and unethical. Ethical is legal hacking, right? A lot of companies, invite hackers to hack their own software so that they can fix the problems in their own softwares, right? Whereas unethical hacking is obviously, which is not, which is illegal, which can be done to, to do anything, to blackmail people or to access information or to manipulate their data, right? Now, malware is made up of two words, which is malicious software. So any software that is not needed, that enters in your system and then does its work, is called a malicious software. So the first kind of malicious software is virus. So virus is something which spreads in your computer and it manipulates and changes your file. It runs in the files, it runs in the background and makes your system slow and does all of these things. Worms is also a type of virus. I mean, kind of virus, but worms, they spread on a network. They spread on the whole network. So worms are more dangerous because viruses, even though it's, virus is kind of restricted to one computer, whereas worms will spread to the whole internet and to the whole network, and it will, get into all of the systems connected to that network. Trojan horse. If you know the story very well, if you don't know it, I'm going to explain it to you in short terms. If you know the Trojan horse story, okay. If you don't, then let me explain it in easy language. So Trojan horse is when there's something which looks very genuine, right? It looks like a genuine thingy, but at inside it is something else. So it's a legitimate looking software or a file, but then when you open it, there is something else inside it, a virus, anything of that sort. Ransomware is when not people, a hacker encrypts your information. It encrypts your information, it locks your files, and they will ask for a ransom. They will ask for money, right? When you, obviously, to open that, if you want your files back, if you want them to be decrypted and you don't want to lose them, then you have to pay some amount of ransom to them, and still there is no guarantee that they will give it back to you. Again, spyware is something, obviously, as it says, spy, right? So spyware is when hackers use this to spy on you. Maybe your camera is being accessed, your microphone is being accessed. Or key logging is when every whatever you're typing is being accessed by someone else and every mouse click is being registered. So this is called spyware, right? Adware is when you get a lot of ads in your system, pop-up ads in your system. Randomly a web browser opens and you get random ads. That is adware. Now, phishing is something, again, it's a phishing is always in emails. It is a legitimate looking email, but then it will contain a malicious link or it will contain a malicious file, and when you click on it, you get hacked or you get doomed, whatever you want to say. Farming is a malicious code. So, whenever we try to download a paid software's free version, also called the crack version from the internet, and you end up downloading something else which is bad for your system, that's farming. Malicious code that you unintentionally download and it starts to mess up with your system. Social engineering is when you play with emotions, when you play with mental state. For example, there's a person who works in X company, but then you have been hired to get information about the X company. So you will get close to that person who works with the X company. You will get so much. You'll make him a friend. You'll start spending time with them, right? And then when when they are in you when they are with you, you can someday you will do something and ask them for the ID password, and you being their friend, they will give it to you, and then you can access the company's data. Now, how to be safe? Obviously, you can put access level and authentication in your system, right? Access rights, access level, you can put it, which user can access what files. You can also put anti-malware and antivirus softwares, right? Obviously, Microsoft Windows already has a installed one, but if you want to download extra, you must have heard the names of McAfee or Quick Heal. You can do that. Anti-spyware or anti keylogger, these are softwares to avoid spywares. You can put biometrics, right? Fingerprint or face ID scanners. You can put automatic system or software updates. Obviously, this is really necessary. You can put two-step verification, which is when you log in with your account, you get an OTP on your phone, then only you enter the OTP, then only you can log into your account. Firewall and proxy servers. Now, what is firewall and proxy servers? So firewalls act as a barrier, They are a wall. They act as a barrier between you, your computer, and the internet. How does that happen? Proxy servers also, let's see. So firewall is like a wall, right? It contains a whitelist and it contains a blacklist. So it contains two kind of lists, right? A firewall is installed on your network. It can be a school network or your home network. For example, it's your school network, and the school wants to block Instagram and the school wants to allow YouTube. The school wants to block Instagram so that the students cannot access, or TikTok, maybe they cannot access Instagram and TikTok, but they can access YouTube. So what will they do is they will put Instagram and TikTok into the blacklist, right? And they will put YouTube into the whitelist. So you can imagine a wall between your computer and the network. For example, you try to type in Instagram, right? So Instagram's address, the wall won't let it enter. It will reflect back. That's how even we make the diagram of it. Whereas whatever app is in the whitelist, for example YouTube, it is going to enter through the wall. So it's a blacklist and a whitelist. A proxy server is a firewall. It acts as a firewall, and it keeps user IP address confidential. Firewall does not do that. Your IP addresses remains to you. Nobody can, someone else cannot access it. And it keeps the web server safe, right, within time limits. So that's what a proxy server does. A proxy server is also a fake server, you can say, right? So every server in the world would have a proxy server, so that when the hacker hacks, it may look like that they have hacked into the real server, but actually it would be a proxy server. So these are few things that you should know about firewall and proxy servers. So thank you so much for watching this video. If you want to join our WhatsApp community where we can answer your doubts for free 24/7, you can check the link in the description below, or you can go to our website, which is www.cambihub.com. There you will find a link on the top of the website which will allow you to join the WhatsApp community. And if you want to mail us, you can mail support@cambihub.com. If you want to mail me for any specific doubts or any business deals, being the co-founder of the forum, you can go to Pranay. You can mail me at pranay@cambihub.com. And please do check out our CambiHub learning portal. It has a lot of new materials, resources for IGCSEs, GCSEs, O levels, A levels, and IBDP and IBCP and MYP, all of these courses, right? So you can go and check the latest deals. You will also find our Instagram and YouTube on the website itself, and our summer programs that we offer. This is Pranay signing off from CambiHub. I'll meet you in the next lecture.